This topic about trees in data structures. Tree is a nonlinear data structures and it has a finite set of one or more nodes, so such that it has a root node and leaf nodes. So in tree, we called all the elements stored in a space called nodes. So in each node can have zero or more children, and a node can have at most one parent. So here, so tree in the sense a node can have any number of leaf nodes, but in binary tree the node should contain at most two child. So it can contain a node with zero child or one child, or at most two child. So in this example you can see, on your left hand side this is what's tree. So in tree, each and every node have more than one number of nodes, but in a binary tree each node contain at most two nodes, so that is called binary tree. So in tree, so we need to understand the basic terminologies. So here, so root node is a unique node in the tree to which further subtrees are attached. So root node, for root node there is no parent node, this is the top of the node. And parent node means a node having further sub branches is called parent node. And leaf node, so for leaf node there will be a no child node, so this is the terminal of the nodes. And interior node means this is a non-leaf node, so it will be not a root node and it will not be a leaf node, so these nodes are called as a interior nodes. And height, so the height can be calculated from the root to the leaf. And child nodes means for example, for this in this example you can consider the black marked as a parent node, and this blue marked nodes are the child nodes. So a parent should contain child nodes. And the next term, binary search tree. So we already know what is tree and binary tree. So binary search tree means it follows binary tree concept, and then value properties. Okay, so here binary search tree means a node should contain at most two child, and another one property, the values on the left subtree should be a smaller value than root node, and the values on present on right hand side should be a greater than the root node. So these are the two important properties we need to concentrate while implementing the binary search trees. So one is binary tree and another one is lesser and greater values of in the subtree. So in this example, you can consider, so x y z. So it should be in a value should be in a lesser and greater order. So in this tree, you can find the example. So here, for the first example 10, so for the 10, that is a root node. For this particular root node there will be a two child 5 and 30. So the 5 should is a lesser than root node and 30 is a greater than root node. So this is the binary search, it follows in the binary search tree concept. And here 5 contain only one node and 30 contain two nodes, so it will be a normal because the node should can at most two child 0 or 1 or 2 child. Okay, on the right hand side we can see it follows binary tree property. It follows binary tree property, but it does not follows lesser and greater than values properties, because 10 is a root node. Here 5 is placed on the left hand side, that is correct, and 45 is also correct. But compared to the 25, so 25 is greater than the root node 10, so it should be placed on the right hand side, but it is placed on the left hand side, so it is not a binary search tree. And the binary tree construction, we need to concentrate on two things. The two operations are performed in binary search tree are insertion and deletion. And while insertion, we need to concentrate on two properties. One is key property and another one is binary tree property. So this is, we already discussed how we have to perform insertion. That means the left side value should be lesser and right side value should be greater. And in binary tree, the tree traversal. So tree traversal is performed in a three ways. One is in order, post order, and pre order. And here you can see the example of insertion. So here the same example. Suppose if you are inserting this 20, first you have to compare with 10, so that is greater, so you should shift into the right hand side. So again in right hand side there will be a value 30, so you need to compare 20 with that 30. that is lesser, so you need to come with the left hand side. So there will be another element is present, so you need to compare with 20 with the 25, that is lesser, so we can place it on a left hand side. So this is insertion. And deletion, so deletion is also performed in binary search tree. So here the deletion is possible if the node can have zero child, or a node can have one child, or a node can have two child. If a node can have zero child means we can easily, that means leaf node, so we can easily delete the element. And if the node can have one child means we can delete the element and replace that value with a single child. And if the node can have two child means we have to find in order successor for that particular tree, and we need to replace the value with successor node of the deleted node. That is the deletion process in binary search tree. See here, you can see here the delete example 25. So here 25 does not contain any value, so any node, so it's a leaf node, so we can directly delete the 25. Suppose if you are deleting 10, that is a root node, sorry, okay, if you are deleting 10, there is a root node and it can have two child. So if you are deleting root node, we need to find the in order successor. So in order successor for this particular node is 30, so we need to replace that 30 with 10 and we can delete the 10. And if you are deleting 5, 5 can contain only one element, that is 2, so it only contains single child, so you can delete the 5 and replace with 2. So these are the deletion properties. Thank you.